Morning, everyone. Our next speaker is Peter Scamarak, former head of AI automation at Workday, presenting on Foundations for ML at Scale, where to start in your organization. By way of background, Peter Scamarak is an entrepreneur, investor, and former head of data products at Workday and LinkedIn. He was co-founder and CEO of SkipFlag, a venture-backed deep learning startup acquired by Workday in 2018. He was an early member of the data team at LinkedIn, and as a principal data scientist, he led data science teams focused on reputation, search, inferred identity, and building data products. Please welcome Peter Scamarach.
Thanks everybody for coming. There's a lot of talks about the details of machine learning platforms today. I'm going to talk about everything else around setting up deployment of one of those platforms for success, because oftentimes some of that auxiliary work is where there's the most difficulty. There isn't enough buy-in for rollout. Companies don't have the commitment that it takes to do these big infrastructure projects, or the applications that you end up applying the ML platform to are not the right ones, and the business doesn't see a return on investment. So there's a lot of things like that to watch out for, and a lot of roadblocks along the way. So I'm going to try to give a crash course in what to expect, things that you can do ahead of time or along the way to make your deployments more successful. So how do you set up machine learning projects to be successful? What are the systems and processes you need to put in place to get the most out of your AI platform? The most successful machine learning applications are directly tied to improving metrics that matter to your business, but how do you identify and prioritize those projects? We'll talk a lot about those patterns that I've learned from talking to many folks who have built these platforms at various companies and many other open source leaders in machine learning, along with my own experiences, both LinkedIn and Workday, as well as doing a machine learning startup and advising and consulting with a number of organizations starting on this journey. So ideally, with the right conditions in place, you'll see an outsized impact across your company as new data products roll out quickly and the machine learning models are deployed at scale. So the first thing to think about, and the most important advice I could really give to everybody here, is to make sure that you work on things that matter to the business. This is the number one mistake I see. So you have to do this foundational work. Usually it's a product manager of some kind or a product leader or an engineering leader to look at the set of problems that in your business that you can apply machine learning to and make sure that you're solving the important ones. And to really do that, you have to understand your core business and how your product works. And you need to think about what are the strategic goals of your business. And then you want to pair a machine learning application directly to those goals if possible, such that when you make an improvement in model accuracy, it directly translates into a change in revenue or a change in user retention or engagement, something like that. If you can't find a problem like that, essentially machine learning and AI is mostly PR, right? It's a nice science project, something that the company might like to point to, but people, realistically, the business folks, sales folks, they won't take you seriously. And then when things go bad, guess what? They're probably going to start cutting these projects that don't have ROI. So build that direct connection between your machine learning application and something that the company or our team values. So as a concrete example of this, people you may know was probably the most successful example at LinkedIn. And so LinkedIn's mission was to connect the world's professionals to make them more productive and successful. And people you may know directly paired what the company wanted to do, which was drive connections, get more people adding to their network, and signing, and also those could be non-users, so getting them to sign up and come onto the site. So it's paired that problem with a machine learning solution, right? So with a small number of engineers, the data team built a production machine learning model that directly impacted the most important metric to the company, right? So on Monday mornings, we would have staff meetings. You know, the CEO, Jeff Weiner, would look at all kinds of metrics across products, across the company, and that one was always critical, right? High priority, whatever that team needed, you know, they would get resourced. And because they built it in this high return on investment, high ROI way, they actually did it with a pretty lean engineering team. So within months, that also drove like I said, new user growth, new people coming to the site, and it created this viral flywheel of user growth that was important as LinkedIn went IPO, and it was important to Wall Street numbers. So that's a pretty high-profile example in a consumer application. It can be a little bit more challenging to do this in enterprise SaaS type businesses where the time before you see impact may be a bit longer. So when it takes time to see results, one of the most important things I can say is get executive sponsorship and support from the top, because deploying an ML platform is a long-term project and things will go wrong. So ensure your data team has strong leadership, strategy, and vision. I'd also add that a good business use case is not enough. Without access to data, your machine learning platform will be useless. In larger companies, my advice is to start, you have to compromise sometimes. So maybe the most important problem doesn't have readily available data yet. So you may have to go to where it's open, go to where training data and label data is available. And work with business units that are amenable to working with you. It can be much harder to convince those high-profile teams sometimes. So once you've identified some possible projects, another step that a lot of folks do poorly or skip over entirely is detailed planning and prioritization. So they may just start working on, you know, what seems interesting, right? Or what seems easiest. You really want to go deeper and think about, you know, what is going to have the most impact with the fewest resources? What's the highest leverage things that I can work on? So if you have a good data team, you have a good talent in place, you have smart people, and you've developed some intuitive understanding of your company's data, there should be no shortage of ideas. And often, you know, even when we'd interview people, they would often come up with very similar ideas to things that we'd been thinking about, you know, at LinkedIn or at my startup. So I think as long as you get smart people in the room, they're going to generate good ideas, but they're also going to generate interesting ideas that, you know, might be a good research paper, but are not good for, you know, a business application, given you have finite resources to invest. And some of them may be too difficult, right? Some of them may be on the cutting edge of research and a little bit too risky, right, relative to something that you could roll out and could have revenue impact immediately. So the main idea is that, you know, you need some filter, you need some way to align these things and make these hard calls about what am I going to staff and what am I not going to staff and when. So the one approach that I've found useful is to build up this kind of backlog or this large list of projects, and then look at your company mission and strategy and find the projects most aligned with those goals that can translate to a real projected business impact, and then rank and prioritize by the return on investment for each of those projects, right? So if there's something that is going to generate, you know, a couple $100 million in revenue, and it takes, you know, 5 engineers, that's probably what you want to work on, as opposed to something that takes 10 engineers and will have unclear value, right? In its most simple form. The other thing is that you have to be careful here because machine learning is on the cutting edge. Somebody with a good idea and a clever algorithm could have a massive impact on your company, and you don't want to cut off that innovation. So what I typically like to do is have, you know, anywhere from like 10 to 30% of the portfolio of projects be these venture bets where maybe you can't quite connect all those dots yet, but they may, you know that there's value if you keep digging in that direction. So always have a little bit of an escape valve and staff those projects ahead of the ROI. So one example of this was skill suggestions at LinkedIn. So our mission, like I said, was to connect the world's professionals, to make them more productive and successful. So one strategic objective to get there was to become the professional profile of record, which means for every white-collar professional, have a very complete and detailed profile, right, including their positions, education, skills, and then everything just works better. You can do better job matching, better recruiting, better advertising, which all have monetary impact, right? And so an expected impact for this might be something like, hey, when we change this flow, instead of just giving an empty text box, we use a skill suggestion model. We expect a mass, an order of magnitude increase in conversion, and then that's going to translate to 20 million more members adding skills to their profile or something like that, right? This was in the earlier days of LinkedIn. And so that actually worked. That product worked. We started with an email campaign. We did an MVP, and then we accelerated and put more gas on the product. So that's one example, and that was done with, I think, 2 engineers, right? So it had a big impact on the company. So if you're able to identify the right projects to work on and to push through your ML platform, the other kind of limiting reagent here is data and data infrastructure. So a foundational thing to set up these projects for success is to invest in data infrastructure. So this is a chart one of my former coworkers, Monica Ragati, created, which is a hierarchy of needs for AI. I think this has already been shown in this conference yesterday. Every conference I go to now has this. But there's a reason. It's really important. A good number of companies that I talk to, everything seems promising. It seems like they are ripe for machine learning. And then when you pull back the covers inside the company, they either don't have the data, they're not collecting it, or it's just not accessible for whatever reason, red tape or regulations. This happens a lot in healthcare and regulated industries, as well as non-consumer industries, non-consumer companies. But even in consumer companies, even in places where you would think this is a prerequisite, the data infrastructure is often pretty messy, and jobs break, ETL breaks. So this is something that you need to, in parallel, invest in heavily. If your jobs are constantly failing and pagers are going off, anything you can do here will have a ripple effect in your machine learning platform. So going further on the topic of data, it's not just that your jobs are running and tables are being populated and logging is working. You also have to think a lot about data quality, standardization or normalization of that data, and data labeling, right? So this all, more time, if you had to invest, $6 out of every $10 here, that's probably what I would do if you want your machine learning to be successful. Because often, people, assuming you're working on the right problem, it's often less about the model architecture. It's more about bad training data or not enough training data, things like that. And so the 30-second version of my advice here would be, if at all possible, so get all your tracking in place, there's a lot of great writing out there about how to do this well. When you have things like text data, you have to think about deduplication and disambiguation. There's a lot of great packages out now to do entity linking and things like that can really help there. And a lot of the great work in BERT and the various language modeling pre-trained models can be very helpful. But then when it comes to labeling data, if at all possible, find a way to affect the UX of your product so that your users, your end users, are labeling the data in the course of their normal activities. So think about things like reCAPTCHA. So when you go, the bot wall that comes up and says, hey, is there a stoplight in this picture, things like that. That's a little artificial because you don't care about labeling stoplights. But if at all possible, in the flow of the product, have people verify, hey, is this the right, does so-and-so still work at this company? Is this the right email address? Things like that. Find clever ways to get them to label it. Because if you have to go to outsiders and pay companies or experts, that gets very expensive. There may be some other avenues like synthetic data that'll help there as well. So in the interest of time, I'm going to move kind of quickly through the rest of these, but you similarly want to move quickly when you're training models. So ML engineer productivity is the next place you really want to invest. Instrument your platform from end to end, because everything from which version of a model you're using, training data, runs, outcomes, weights and biases is what's shown here. That's a good example of how to do this. You want to log all that information so that you can reproduce the state of your model at any given time, and if you had a different scientist training a model, you may get different results. You need to understand why that happens so you can make improvements. The mean time to see results of a model change is pretty critical. And it's not just about throwing more horsepower at a problem for a training run. Even the time it takes to make that change and then kick off the training run, sometimes that's hours in companies, and that's a killer, right? Because that means you can only maybe test one change a day. And in many cases, the infrastructure and the developer tooling is falling apart, and they can't even do that, right? So do whatever you can to make that really robust and repeatable. And then the other thing in terms of productivity, oftentimes people do runs and then they flounder a bit when it doesn't work. So my advice on developer productivity and R&D for model improvements is to always change one thing at a time and start with a very well understood baseline, right? So papers with code is a great example in academia where a lot of papers cite results on data sets. People are publishing code, people are publishing those numbers on standard data sets. If your problem can map to something like that, start there. And make sure that you can replicate that, and that way you're avoiding a lot of complications, and then iterate slowly from that point on that problem. So this leads into the next topic, machine learning testing, right? So those benchmarks are a kind of test, right? They're an end-to-end test where the entire training run happens. But that leads to the larger question: what does testing look like for machine learning? You need to change a lot of your underlying assumptions about testing here, because the real world data that you're operating on changes over time, right? And which leads to things like, if you have tests, it leads to stale tests and benchmarks that are not representative. So it's better to at least use those out-of-date benchmarks. I'd recommend you start there. But then you need to keep up with your actual problem and your data. If you are doing those things like instrumenting your application to collect the labels and training data, guess what? Your UX is changing. It's like changing a survey design. It's going to start shifting what your problem actually looks like and what your training data looks like. The other thing that happens is when data scientists do write tests, they break frequently as upstream libraries change or the data ETL breaks. So the other thing you want to do is decouple the testing of your data and infrastructure from the testing of your machine learning models as much as possible. So definitely have those end-to-end tests, but also have decoupled unit tests for each part of your pipeline, and make sure that it's all well instrumented. So the other tip that I would have is do things like generate synthetic data, data sets and labels where possible that are generated from a phenomenon that you understand, right? So some kind of generative model, maybe a set of standard questions with predefined answers from a knowledge base if you're using text or something. And that way you know exactly what's in the data and what exactly should come out. And run that end to end and make sure that your model behaves appropriately. So that leads to the next topic, which is ML ops, right? So the main goal here is there's the offline world, there's testing, there's synthetic data, things like that. Now, when you really go to production and you're deploying live, more headaches happen. And one of the big ones is that data scientists are mostly not software engineers, or there's usually some spectrum or divide between research and production. And those are the folks who also need to, right now, typically support those models in combination with IT or ops. So what you really want to do is invest in ML ops automation before you commit to a fast cadence. So generally, I would say release early and often, always be pushing. That cadence is critical for teams. But in this particular case, to make that effective, you need to invest in repeatability and deployment of your platform. Otherwise, your R&D folks are going to be fighting fires constantly and doing manual deploys and helping IT and ops, and that's very hard to escape from. And so the main thing to think about there is to track and minimize the median time to deployment and make that very repeatable without failures. A good thing to read is Google's ML test score paper, which goes through how to assess this in your company. So the second to last thing is monitoring. So if you're able to deploy repeatably, how do you know? Well, because you're monitoring everything, right? And traditional monitoring is usually fairly simplistic. It's tracking things more related to servers than to things like model accuracy and quality. And again, all those other issues with testing come up here as well because you have this ever-changing set of data sources. So what is normal is actually changing all the time. So traditional monitoring struggles with that because it's often rules-based alerts, right? But if you have a company where, things are growing, you're getting more adoption, getting more users, all those norms are going to be shifting all the time. And you may just have, if you think about news, right? The meaning of words change, your language models are going to change. So change is constant here, and features drift and break over time. So you're really going to have to rethink this. There's some good startups that are working in this space. I'll put some links up on Twitter related to how to think about this. The last thing I would say, these have all been fairly, nuanced technical topics. But a big one that people skip over as well is communication. And so within your company, you need to kind of win hearts and minds of everybody that, hey, this is going to be a big deal for our company, but they're going to have patience to see results. One of the things you can do is provide internal basic training for AI so that everybody understands at a basic level what you're doing and why it's difficult. And then do things like track key metrics and provide cumulative progress. So I mentioned papers with code. Imagine a version of that, but looking at your cumulative progress over time on a particular problem, and then tying it to some of those business metrics and things like weekly reports. The other thing is you'll be spread very thin when a lot of questions come in about how models are working, either from your end users or your salespeople, and particular issues and customer support. So you probably want to invest in explainability at some point. To respond to those questions somewhat automatically, and then also for your team to take the communication that they're getting from customers, be able to lift up the hood on the model and see why it's happening so they can improve it. And finally, I would say celebrate your wins. This is a long march to get these things deployed successfully. So you've got to build up that excitement and energy and make heroes of the people using your platform and your partners in shipping data products.